Good morning everyone. So this is the third chapter, stack. In this we are going to learn first the introduction part. We all know about the string, list, set, tuples, that is table, that we have learned in the 11th standard. In this stack we are going to learn about firstly the data structure. What are the data structure? Data structure means what? If we have different kinds of elements, like, or we have different types of data, the same way we can apply different operations like reversal, scaling, counting of elements, etc. on the list and string. So what is exactly the data structure? The data structure defines a mechanism to store, organize and access the data along with operations, that is processing that can be efficiently performed on the data. Okay, for example, string is a data structure containing a sequence of elements where each element is a character. Okay, and this what will happen, we are going to consider the different data types, string, integer, these are the data types, and we are providing the different values to that particular data type. Okay, so that is your data structure. So we have used different data types in Python for storing the data values. Such grouping is referred to as the data structure. Now we are going to see what is stack and queue are two other popular data structures used in programming, although not directly available in Python. It is important to learn this concept as they are extensively used in the number of programming languages. In many of programming languages, stack and queue are used. In this chapter we will study about stack and its implementation using Python as well as its application also. Now we will see what is stack. We have seen piles of books in the library or stack of plates at home. Okay, we are going to see what is exactly this stack of plates. These are the stacks of plates, means different numbers of different plates are having on one another, and we can count that plates. So that is the stack. Over in stack we have different plates. The same way books also, one on one another there are different books are placed. So we can say it as it is the number of books and number of plates, so that is called as stack. Okay, so we can say that this is because in a large pile, we can say that it is a piles of books in the library, that is a stack. Okay, stack of plates at home also. Okay, the same way we can say that likewise, to remove a book or a plate from such a pile, we always delete from the pile the object from the top only. From the top only we can remove one of the plates, or we can remove one of the book from the top of the stack. Okay, this is because in a large pile it is inconvenient to add or remove an object from in between or bottom. Okay, it is inconvenient, we cannot able to remove the object from in between or from the bottom. Okay, such an arrangement of elements in a linear order is called a stack. Okay, such an arrangement of each an element is in the linear order is called as stack. We add new elements or remove existing elements from the same end, commonly referred to as top of the stack. From the top of the stack we are removing the plates also, or we can remove the books also. Okay, so it does follows the last in first out. This is the last plate, this is the last book, so that's why it is the last in first out. That is LIFO principle over there in the stack ka concept. This is the element which was inserted last. Okay, the most recent element will be the first one to be taken out of from the stack. Okay, so over here at the data structure, a data structure in which elements are organized in a sequence is called as linear data structure, and these elements are organized in the linear sequence, that is called as linear data structure. Now what we have, application of stack. The same, some of the applications of the stack in real life: pile of clothes in an almari, then multiple chairs in a vertical pile, bangles worn on wrist, pile of boxes of eatables in pantry or on kitchen shelf. Okay, so these are the applications of stack. Over here we have seen already the plates and books also. So some of the examples of application of stack in programming are as follow. When we need to reverse a string, the string is traversed from the last character till the first character. Okay, so some of the application of stack in programming are as follow. When we need to reverse a string, the string is traversed from the last character till the first character. Okay, from the last character to the first character, that is, characters are traversed in the reverse order of their appearance in the string. This is very easily done by putting the character of the string in a stack, right? So over here we have one of the sentence, and we are calculating the character over there. So the last character is at the bottom of the stack, so that will be the stacking one by one element. So the first one will be your first character, right? So we are moving from last to the first. So this is the application of what? Stack in programming. Okay, so we use text image editor for editing the text image, where we have options to redo or undo the editing done. Okay, so we use text image editor for editing text image, where we have options. We have image editor over there, and we have editing this image or the text, and we have options redo and undo. The editing is done. Okay, we can redo also and we can undo also. Okay, when we click on the redo undo icon, the most recent editing is the redo undone. Okay, in this scenario the system uses a stack to keep track of changes made. In this scenario the system uses a stack to keep track of changes made. We have to keep the track of changes made to the overflow. Okay, that is one of the application of stack. Over here we are considering the image, or we can say that text also. We have option redo undo also. We are editing that redo, we are editing that text and image. So when we click on redo undo icon, the most recent editing redone undone is done. So in this scenario the system uses a stack to keep the track of changes made. Okay, we are over here also we are using stack. Now the next application is what? While browsing the web, we move from one web page to another by accessing links between them. Okay, we are moving to next and next page while browsing the web. When clicking on the link, we are moving to the next one. Okay, in order to go back to the last visited page, we may use the button back on the browser. Also we can use back button also. This is also one of the link. Okay, so let us say we access a web page P1, from where we move to web page P2, followed by browsing of the web page P3. Okay, currently we are on the web page P3 and we want to revisit the web page P1. Okay, we may go to the previously visited web page by using the back button of the browser, right? So on clicking the back button once, we are taken from the web page P3 to the web page P2, right? Another click on back shows web page 1, right? Firstly, we are on web page P1, then we are moving to P2, then we are moving to P3. If we are going to back button, then P3 to P2, P2 to P1, right? So in this case, the history of browse pages is maintained as a stack. This is also one of the stack application. While writing any arithmetic expression in a program, we may use parentheses to order the evaluation of operators. We are having different evaluation operators. While executing the program, the compiler checks for match parentheses. That is, each opening parenthesis should have a corresponding closing parenthesis, and the pairs of parentheses are properly nested. Okay, over here we have different parentheses. Okay, while writing the arithmetic operations, okay, we are using different parentheses for each and every operation. Okay, so these pairs of parentheses are properly nested, right? In this case, parentheses are mismatched. The compiler needs to throw an error, right? So to handle the mismatch of parentheses, stack is used. We are using stack, that is one after the another parentheses are using with the different arithmetic operations. Now operations on stack. As explained in previous section, a stack is mechanism that implements LIFO arrangement. Hence elements are added and deleted from the stack at one end only. Over here we are using LIFO, that is least in first out. Okay, in the stack, the end from which elements are added or deleted is called as top of the stack. Okay, from the top of the stack we are deleting and adding the elements. Two fundamental operations performed on stack are push and pop. Okay, in this section we learn about them and implement them using Python. Push and pop operations we are going to see now. What is push? We already know in some of the clinic or some of the shop there are written push and pop on the door of the shop, or we can say clinic. So already we know what is push and pop. So over here at the stack definition, what is push? Push adds the new element of the top of the stack. Push means what? We are pushing something, so it is adding the new element of the top of the stack. So it is an insertion operation. Okay, we can add elements to the stack until it is full. Okay, a stack is full when no more elements can be added to it. Okay, so trying to add an element to the full stack result is an exception called as overflow. If we are adding the elements on the top of the stack, it is called as overflow. Okay, the exception is what? Overflow. Then what is pop? Pop operation is used to remove the top of the most of the element of the stack. Pop means what? Pop means what? On the over here at the stack definition, pop means what? Removing the elements from the stack. Okay, so that is element of the top of the stack. It is delete operation. We can say it is a delete. So I'm just thought all know about push only, not pop. Pop is over here about the stack definition. Okay, so it is a delete operation, and simply it is a delete operation. We can delete elements from the stack until it is empty. Okay, until it is empty, will be deleted. There is no element in it. Okay, trying to delete an element from an empty stack result in an exception called underflow. Okay, if we are deleting the element from the stack, empty stack, the exception is what? Underflow. Here is the diagram push and pop operation. You can see over here. Firstly, it is empty stack. Okay, then we are pushing something. Then again we are pushing something, then we are popping something, then again we are pushing something, again we are pushing something, again we are popping something. You can see over here 4 is pushing again, and then 4 will be popped. Again 3 will be popped. So the remaining one is 1. Then again 1 will be popped. So the stack is empty. Understood? So this is the stack concept. Over here we have push and pop operations. Okay. Over here we are using LIFO ka concept, that is list in first out. Now implementation of stack in Python. Okay, we have learned so far that a stack is a linear and order collection of elements. The simple way to implement a stack in Python is using the data type list. We are using list over here. We can fix either of sides of the list as top to insert remove elements. Okay, it is to be noted that we are using built-in methods. Over here we are using built-in methods, that is append and pop. Append means adding something and pop means what? Pop means removing something. So we are using append and pop operations, built-in methods we are using over here. So over here, as built-in methods, insert delete elements at the rightmost end of the list, hence explicit declaration of top is not needed. Okay, so over here we have written some of the programs, stack programs. Insert delete elements, we have considered it as a glasses. Check if the stack is empty, no glasses in the stack. Find the number of elements glasses in the stack. Okay, then read the values of topmost element, that is number of the topmost glass in the stack. The program shall define the following functions to perform different operations. So over here let us create an empty stack named glass stack. We will do so by assigning an empty list to the identifier named glass stack. Glass stack is equals to list method over here we are using. Okay, now what we are going to use, def keyword is for Python, then is empty we are using, and over here if it is removing the element from the empty stack would result in underflow. So okay, if it is empty stack it is result in underflow. So def is empty in bracket glass stack. Okay, if length of glass stack is equals to 0, return true, else return false. Okay, so this is the code. Now we are inserting push operation over here. The name of the stack in which the element is to be inserted, glass stack, and the element that needs to be inserted. Okay, we know that insertion of an element is always done at the top of the stack. Okay, insertion is always at the top of the stack, so hence we shall use the built-in method append over here we are using, and we are using exception overflow over here. So def operation push, op is what over here? Op is operation push. Okay, push operation is over here. OP, that is operation push, glass stack comma element, then glass stack dot append element. Elements we are appending means adding over here on pushing. Okay, so after that we are using def size glass stack, return length of glass stack, that is size only. Okay, we are mentioning the size first and then we are calculating the length of glass stack. Okay, now we are using top element over here, def top glass stack. If is empty glass stack, print stack is empty, return none. Otherwise x is equals to length of glass stack, element is equals to glass stack, x minus 1, one element will be removed, then return element. Okay, so over here the function name top to read the most recent element top in the glass stack. So this is the top of the glass stack. We are mentioning the top of the glass stack. If it is empty, then print stack is empty, otherwise none. It will go to else part. We are calculating the length, then we are removing something, and then return element. Okay, so that is operation name of pop to delete the topmost. The name operation pop is basically useful for what? Delete the topmost element from the stack. So over here we are using operation pop glass tag. If is empty glass tag, print underflow, return none, else return glass tag pop. Okay. So we are using operation pop over here, glass tag. If is empty glass tag, return underflow, return none. Otherwise it will goes to glass tag dot pop. That is, we are removing some of the element over here from the glass tag. A function named display to show the contents of the stack. We are using over here def display glass tag. X is equals to length of glass tag over here. We are first displaying the glass tag, then we are calculating the length of the glass tag, then we are printing current element in the stack are for I in range x minus 1, minus 1, minus 1. These are the I in this range. Print glass tag I means what? We are calculating x minus 1, minus 1, minus 1. Okay. Once we define the above functions, we can use the following Python code to implement a stack of glasses. Glass stack is equals to list, create an empty stack. First we are creating the empty stack in the list. Add elements to stack. Element is equals to glass 1. Glass 1 is one of the element. Print pushing element is comma element. Okay, we are pushing the element one by one. Then pushing on push glass stack element. Now we are calculating second glass 2 element. Over here this element will be pushed. Now display number of elements in the stack. Current number of elements in stack is size glass stack. Okay, we are calculating the size of the glass stack. That is number of elements in the stack. Now delete an element from the stack, that is on pop. We are using on pop over here. We are using on pop over here. On pop means we are deleting the element from the stack. Then again we are adding something glass 3 over here, pushing the element on push. Now display the last element added to the stack. Print top element is top glass stack. Display all the elements in the stack, display glass stack. So lastly what happen, at the top of the element we are just printing the top glass stack, and all the elements in the stack will be displayed. That is display glass stack. After that delete all elements from the stack. We are deleting all elements from the stack. So while true, atom on operation pop glass stack. If atom is equals to none, print stack is empty now. Okay, pop operation pop we are using over here means we are deleting one by one from the stack glass stack. Now pop element is atom. So atom is what? Over here we are using atom. Where is atom? Is none. So print stack is empty now. Otherwise it will move to pop element is atom. Whichever atom we have, it will printing. Otherwise it will go to else. Okay. So that is delete all element from the stack. So what is the output? This is the output. And lastly underflow is over there because of pop, because we are deleting all the elements from the stack. So stack is empty now. Okay. Why we are using underflow? Because over here they have mentioned the underflow for what? Underflow for pop operation. Trying to delete an element from an empty stack result in an exception called underflow. Okay, if we are deleting element from the stack and the stack is already empty, then it will go to the underflow. Okay, now the next one is what? Where it is? Understood everyone? What is exactly the pop element? Now the next one is notations for arithmetic expressions. Notations everyone know, arithmetic operation also know. Arithmetic operations means plus, minus, into, division. And notations means what? We are defining the notations for that particular arithmetic operation. So the expression follows infix representation and are evaluated using DODMAS rule. Okay, so push mathematician Jack Lucaswise in the 1920s introduced a different way of representing arithmetic operation called as Polish notation. In such notation, operations are written before their operands. So okay, these are the operands and these are the operations. X is operand, plus is operation. Okay, so what is notation? For example, we can write x plus y in Polish notation as plus xy. Okay, this is the Polish notation. So this is called as prefix notation, as we prefix the operator before operand. Okay, operator before operand. So that is Polish notation. Look at this one. This is x plus y and this is plus xy. Understood? Now next one is what? By reversing the logic, we can write an expression by putting operators after their operands. For example, x plus y can be written as xy plus. This is called as reverse Polish notation, or we can say as postfix notation. Okay, this is infix and this is postfix. So these are the infix, prefix and postfix notation. Infix, operators are placed in between the operands. These are the infix. X into y plus z, then 3 into bracket 4 plus 5, then x plus y divided by z into 5. Then what is prefix? Polish. Okay, so this is what? Prefix operation. So plus z into xy, this is the prefix one. Now first operation is your plus 1 and then into. Then again this is what? 3 into 3 plus 4 5. Okay, then again divided by plus xy into z5. Okay, this is the prefix Polish notation. Then postfix, reverse Polish, operators are placed after the corresponding operands. So we are putting over there xy into then z plus. So you can say it as, if it is x into y plus 1, then why we are taking z first? Because it is x into y. So we can take it as into xy plus z. This is also possible. Okay, now this into 3 plus 4 5. Then again plus xy. Now over here this is x plus y divided by z into 5. That's why division operation is written first, then plus xy into z5 is written. Okay, now same way the postfix, that is reverse Polish operation, is given. Now next one is conversion from infix to postfix notation. So how we can convert the infix to postfix notation? It is easy for humans to evaluate an infix expression. Consider an infix expression x plus y divided by z. While going from left to right, we encountered plus operator. Okay, so do add x plus y, rather evaluate y divided by z. This is just an explanation of this infix and postfix notation. Okay, so over here what they have mentioned, we have x plus y divided by z. So first we are writing plus xy and then we are writing divided by z. Okay, that is, we can consider it as but we do not add x plus y, and rather we evaluate y divided by z followed by addition operation. Okay, so what they have written, this is because we know the order of precedence of operators that follows BODMAS rule. But how we can pass this precedence knowledge to the computer through an expression? Okay, so over here they have mentioned BODMAS rule. What is BODMAS rule? We have the expression x plus y divided by z. So what they have written, but we do not add x plus y and rather we evaluate y divided by z followed by addition operation. First we have done addition operation, then we are dividing it. Okay, so that is what BODMS rule. So in contrast, prefix divided by prefix, or we can say postfix expression, do not have to deal with such precedence because the operators are already positioned according to their order of evaluation. Hence, a single traversal from the left to right is sufficient to evaluate the expression. In this section, we will learn about the conversion of an arithmetic expression written in infix notation to its equivalent expression in postfix notation using the stack. Infix notation means what? What is infix notation? Infix notation means what? We are trying to read the operations as written. And what is postfix? Postfix notation. Postfix notation means what? We are writing first the operands and then we are writing the operations. That is postfix notation. Okay, using the stack. So over here infix and postfix are given, not prefix is given. Prefix means what? First you are writing the operations and then you are writing the operands. So we are using the conversion from infix to postfix notation. We are just writing the postfix, that is reverse Polish. Okay, so that is only, and you have to remember the BODMS rule. Okay, that is what? X plus y, and then we are writing y divided by z. Okay, so that is what your BODMS rule. That is just, you have to remember the order of precedence of operators. Okay, now what we have written, write an algorithm to convert an infix expression into equivalent prefix expression using stack. Means over here what you have to do, first you have to consider one of the operands and operations and return in the infix expression. Okay, then we have to convert it to the equivalent prefix expressions using the stack. Okay, that is only you have to write the algorithm over here like this only. You have to take this infix, then you have to take the prefix. So you have to consider one of the algorithm. First you have to take one of the variable operands, then you have to take the arithmetic operations, then what you have to take, input you have to take, then you have to write the infix operation over there. Okay, infix you have to write. Okay, how you can write the infix expression, that you have to think. After that you have to consider the prefix notations in the stack. Okay, and then you have to consider the concept like how we can convert infix to prefix one using the stack. Okay, so this is the algorithm over here they have mentioned. Conversion of expressions from infix to postfix notation. Firstly, create an empty string named post expression to store the converted postfix expression. Okay, empty string you have to consider. Then you have to take input over here, variable, say in expression. For each character in expression, repeat step 4. In step 4 what they have written, if character is a left parenthesis, then push on the stack. Okay, left parenthesis means we will see one of the example also over there. Okay, else if character is a right parenthesis. Okay, right parenthesis and left parenthesis, and then you have to take it to the push one. Okay, that is in the detail algorithm. You can say it is a detail algorithm. Means what, you have to consider one of the infix expression. For that purpose you have to write the parenthesis, left parenthesis, right parenthesis. Then you have to pop something from the stack and append to the string. So pop the element from the stack and append to the string. Pop means what, you have to remove the element from the stack and you have to add it to the string. Okay, then post expression until the corresponding left parenthesis is popped. Okay, over here what happens, you have to post expression until the corresponding left parenthesis is popped. Okay, post expression you have to write until you have to remove the left parenthesis. Again what, while discarding both left and right parenthesis, again this is what else if ka part. Then again else if, that is character is on the operator. Again you have to think about the operator. Okay, understood? Firstly what you have to take, listen over here. Firstly what you have to take, you have to take left parenthesis, then push on the stack. Stack mean left parenthesis you have to push. Okay, then right parenthesis you have to consider. For that purpose you have to take else if. Then character is an operator. Okay, firstly it is right parenthesis, then you have to consider as a operator. Okay, if the precedence is lower than that of operator at the top of the stack. So over here what happens, if it is precedence is lower, then that operator is at the top of the stack. If the lower precedence is there, means plus, into, minus, divide. Lower one is what, plus, and the higher one is into. So if it is lower one, then the plus will be at the top of the stack, and in the bottom of the stack there will be into. According to the precedence you have to think, according to your input you have to think. Okay, then you have to remove something from the stack. Okay, again you have to consider one of the operator, then you have to consider one of the string. Okay, then post expression you have to use pushing something, again removing something, again you have to push something, again you have to add something. These operations you have to use: pop, push, append. Okay, according to that you have to consider one of the example. You have to think one by one according to your expression. First parenthesis, then operators, then operands. Then you have to put according to the preferences, according to the preferences, precedence on the stack. Okay, so lastly pop element from the stack and append to the post expression until the stack is empty. Okay, and then output post expression. This is one of the example over here you can take. Listen over here, I will directly explain you this example. Symbol this one: push, append x, push plus, append y. Okay, so what you have to remember, for the operands you have to use append, and for the operators you have to use push and pop. So over here I am using just push, and for the operands we have to use append. Okay, so it is initial stack empty, postfix string, post expression. Okay, we are using postfix over here. This is empty, so we are putting parenthesis left, again parenthesis left, parenthesis left, parenthesis left. So what is the expression? This is empty one. Initially stack is empty, so postfix operation we are considering over here. Okay, so what we are considering over here, firstly this one, then append x, x append, then plus, and then xy. Okay, so what you have to consider over here, first you have to take in parenthesis left, then again x will be there, again push plus. So plus will be there. Then again append y. So y is there. So what will be the expression? What will be the expression over here? That you have to consider x into y. Okay, why x into y? X into y, not x plus y will be there. This is by mistakenly written x into y. This is x plus y. Okay, x plus y. Okay, over here x plus y should be there. Now this, take this one. This is pop 1. So postfix expression. Postfix means what? First you have to write the operands, then you have to write the operations. Okay, x into y, xy plus, again xy plus, you have to push what? Divide operator. Then again firstly you have to push divide, then parenthesis left, then divide parenthesis left. So what will be the answer? X, y plus and lastly z. Okay, so what you have to do is firstly you have to written over there divide. So the answer will be x, y plus divided by z. So this is postfix operation. Postfix में क्या होता है? In postfix what happens? So in postfix what happens? Firstly you have to take x, y plus, then xy plus, again xy plus and xy z. So appending z over there, and we are considering the operators over here, divide operators. So what will be there? We are using postfix. So it is x, y plus z divided by. So this is your answer over there. Okay, this is by mistakenly written this one, so you have to just put over here slash, that is divided by z. Okay, now next one, into operators. So over there we are appending 8 over there, appending this. So this is the final stack. Over here this is putting the final stack, xy plus z 8 into dividation operation. So finally the conversion of this infix conversion you have to do over here. So what is the infix conversion? Infix conversion is what? X plus y divided by z into 8. This is the infix conversion. Understood? Postfix, infix, first you have to learn, then just you have to take one of the example. This is the example given. You have to consider this example. Okay? And in this example you have to firstly push parenthesis, left parenthesis, then you have to push operators, and then you have to append the operands. Okay, and then you have to go to postfix, and finally you have to do the infix expression. So this is your postfix operation, and this is your infix operation. Okay, so that's it for today. If you have any doubt, you can ask me in the comment section. Thank you so much.